Hi guys. So I was watching this little video the other day from another channel called Learn Electronics, and he was producing a tone control. Now I've been experimenting. I want to see if I can build a little tube amplifier. Got some vacuum tubes here, or valves, and that's up and coming. But I figured that I might actually build that eventually in a little case or something like that, and I would need a treble and a bass control amongst other things. And I thought this might be a good little circuit to try out. So what this guy produced was a little board with a couple of potentiometers on there for bass and treble, but he produced a little board that depends on having the potentiometers on wires, and that is not what I would want to use. I would want to mount the whole little board with the potentiometers to the front panel of a amplifier case. So I decided to try out his circuit, which seems to be based on a circuit that is kind of well known. Where is it? Over here. So I stole his circuit there to try it out as a starting point, and it seems to be working reasonably well, but he didn't actually test it out. He just said this is the circuit, and he explains how it works, so feel free to look at his video. I'll put a link in the description of my video here, but I wanted to take it a little bit further. So what I've actually done is I copied the circuit into KiCad, and I put on there a couple of screw terminals for the input and the output, including a larger one, which I'll show you in a minute in case I actually do use it in a finished project. Sorry. So I came up with this. Let me see now. Where's that? There. Came up with a little single-sided circuit board that can do the whole thing, and of course, to save etching compound and everything else, I usually flood the whole background with ground. So that's just what I did, and I actually have the little board here, and I created a little PCB for it. If you want to know how to make these PCBs, it's really very simple and easy to do, and I have videos on that. If you like, I can put some links again into the description. So the aim of this was to make a little board that has the potentiometers actually mounted on the board. So therefore, I made up a little cardboard version here so you can see how it would mount, which we'll do in a second. I also put in 4 holes here. If I ever produce this board properly, I will probably send it to one of the PCB makers and get a double-sided board, and then I would use this kind of it's like a removable insert which would mount on this side of the board like so. And I did drill some holes, but they're not big enough for the pins, but I'm not planning to use it for this test board anyway, so I didn't deal with that. So that's what that is all about. Then you don't have to use the 2 on the side here, but that's just an option. Any case, so it would mount to the panel like so, and it would, the potentiometer nuts would hold it in place. And I'll do up the little nuts here, just by hand. This is actually a piece of cardboard that I've just made up for demonstration purposes. There we go. And then we can put knobs on it. There. So that's kind of how it would be on front panel, and then you can adjust the values. This location here is 0, so that they're off, and that location here they're completely on, so that is the highest treble and the highest bass. And I found that I set the controls to about there, it gives the most linear response without affecting the output. So let's have a look on the oscilloscope what this thing does. Okay, so now we have the oscilloscope connected. The yellow trace is the input and the pink trace is the output. So you can already see that the input is 500 millivolt per division. I've got it set for 1 volt peak to peak. But the bottom one is set to 100 millivolts. And there is therefore some attenuation in this circuit, and that tells you that this circuit would need to be placed between a preamplifier if you want to input something with low signals, such as a microphone or things like that, so that it wouldn't be attenuating the input unnecessarily. But in any case, I've got it set currently to 18 kilohertz, and at that frequency we do not expect this bass control to have much effect. And as you can see on the pink output there is not any noticeable effect really. But if we hit the treble control, we can make it go way up and we can make it go way down. So if I got the treble set to maximum, we almost get coming out what goes in. In any case, if we now change the frequency to something like a very low frequency, let's say 80 hertz, then we have to change the frequency display here. And now the treble control, as you can see, has little or no effect on the output, which is what you would expect. But the bass control doesn't seem to have as much range perhaps as the treble control has, but that is kind of as expected and appropriate as well, I think. So it seems to be working. Said this one doesn't affect it, but in order to really see what's going on with the frequency response of this thing, we need to use a Bode plot. Now, you might have heard people refer to things like Bode plots, Bode plots. They all pronouncing it wrong. The guy that invented it, he was a Dutch guy, and his name was Bode in English, but in Dutch it's Bode, and it is pronounced Bode. So, and he wanted his name to be pronounced properly, so you've heard it here first. I'm a Dutch guy, I know how to pronounce it, so it's Bode. In any case, in the old days, they would have to go and make multiple measurements and calculate the phase and the gain or loss and so on, and plot it on some graph paper. But nowadays we're lucky because we got oscilloscopes that can actually do that, and we can just select it over here, and then we can go and make some settings. And I did a little test earlier, so I've pre-selected those. The input is channel 1, the output is channel 3. We're using high impedance as the output, input, and so on. So that should be fine for what we're doing here. You can set it to 50 ohms if you're working with radio frequency circuits or what have you that have a 50 ohm value. In any case, we want logarithmic output, all good. And we want wave display. You can either have a wave or a table. We'll look at that in a minute. So we can say start. So in the background you can see it is actually outputting on the yellow, and it is reading the magenta or pink version. I did a previous reading over there which is still visible in the background as a, but sometimes this telescope goofs right at the low end there. I'm going to hit start again and it should fix that up. There, that's better. That funny appendage over here, obviously a bug. So I've got both controls set to the middle, and the pink, as you can see from here, is the gain, and the frequency, the phase is the green one, and the phase is relatively steady at 0, which is good, and the trace is reasonably level, but it's got a little bit less high gain. So therefore, if we turn the treble control up a bit, we should get better high frequency. Let's try that. Let's see what happens. We didn't touch the bass, so therefore that's the same. As you see, we have a bit more on the high end now. You can probably turn it up a bit more. Let's have a look what that does. Just trying to find out where the most linear. If it was perfectly linear, there would be just a straight horizontal line. But it varies a little. You see, now we have a dip in the middle, but we have more on the output. In any case, in a real world application, you may not even notice that our ears are not that finely tuned, but there are settings on these controls, obviously, that can make it more or less linear. But let's have a look now. If I turn, I'll leave the bass in the middle here and turn the treble right off and compare that. Now we see that the phase angle is I think when it is positive it is capacitance, and if it's negative it is inductive or something. Well, I might stand corrected on that, I don't. Yeah, so now we have, see the treble way down, minus 135 almost on the phase angle, and we are minus 45 decibels. If I now turn the treble as high as it goes, and of course we are interested in the magenta or the pink trace the most. So now it has the high frequency is not attenuated at all. There's a dip in the middle though. And what happens if I turn the bass right up? I think it's goofing up again. I'll have to run it again because the bass value should be higher than that. Just going to run it again here. Yeah, that's better. As I said, it seems to have a little bug there, and at the beginning sometimes it sloughs off. That was an error over here. So let's turn both of them completely off, attenuate them. You can see on the background there that the pink magenta trace is very low. Now I've got the treble set halfway, but the bass is still at the max, at the minimum I mean. So all in all, it seems to be working. And now we have the treble is good, but the bass, let's give it a quarter there. Now we have higher bass response, but less treble. So yeah, you can kind of play with these controls, but if you put this on an amplifier, then of course your hearing will tell you what you most prefer, that you find the most pleasant. But the control nevertheless is working. We can reduce the high frequency or the low frequency. Just a little bit higher. They're both pointing at each other like that. One more time just for fun. So that gives us similar amount of attenuation on bass as it is on treble, but there is a hole in the middle there, which is actually probably at around, this is 500 hertz here, probably at a couple of kilohertz maybe. That probably wouldn't actually sound too bad, but as I said, it seems to be working on the whole, so I can use this circuit, and that's what it does. Oh, now if you wanted to see the actual values in the chart, you can see that the at 50 hertz there was minus 5 dB. It goes up minus 4, still kind of minus 5, just about at 200, minus 5. Then it dips down to, where does it dip down the most? 11.9. Yeah, that's a couple of thousand kilohertz, 2.5 kilohertz. It is, it's got a dip in it, and then goes back up again to 5, 4, 4.5. Now, the component values that I use on this board, none of them were very accurate. Like, instead of 222 nanofarad, there was like 226 on one and 218 on another, and 2.6 instead of 2.2, and so on. If I got more accurate components, maybe that little dip in the middle wouldn't occur. I don't know. But in any case, I believe it actually is working good enough as it is, and I'll be using it on some sort of future little amplifier, and that is that. Okay, so that's all I've got, just a little adventure there. If any of you guys are interested in the PCB, then I could actually send it to one of the PCB makers, like PCB Way, Yale PCB, Next PCB, whatever it is, and then I believe you can order the actual boards. But if anyone's interested in that, I can do that. But other than that, I will put the KiCad files to download. If anyone wants it, just put it in a comment if you would like to have access to the files or whatever, and I could probably accommodate that. In any case, this is all I've got, as I said, and I'll see you guys later. Don't forget to like and subscribe and all that kind of stuff, and I'll see you guys next time.